Hi, Challenge B. This is Logic Lesson 25, and it's on using truth trees to check for self-contradiction and tautology. So you might remember we already used truth trees to check for consistency, and now we're going to learn how to use truth trees to test for self-contradiction and tautology. So first of all, we'll look at the self-contradiction. So a proposition is a self-contradiction if and only if its decomposition results in a completely closed truth tree. All right, so let's decompose this. And in this lesson 25, they're not asking you to number and justify each line, just to work out the truth tree. So this is a conjunction, and we know that a conjunction decomposes like this, not P and Q. Right, we have not P here, and here's another conjunction which decomposes to P and then Q. And here you see we have not P and P, so this, we'll just put an X to show that it's a closed branch. And so there's only one branch in this problem, and it's closed. Therefore, it is a self-contradiction. And now over here we'll check for tautology, and the way you do that is you negate the proposition, and if the decomposition results in a closed tree, then it is a tautology. So you have to negate the proposition to do the test for tautology. So instead of writing this whole problem over again, I'm just going to negate the whole thing. I'll put some brackets around there and negate it. All right, so here you see we have a negated conditional. And the way that you decompose a negated conditional is, well, you have the first term just like it is, so not P or Q. And then the second term is going to be negated. So then we would have not P and Q. All right, we will go ahead and decompose this term first. So we know a double negation is just P and Q, and this decomposes to just P and Q. All right, so we're finished with this one and this one, so we'll check them off. And now we're just going to decompose this negated disjunction, and a negated disjunction just decomposes as, well, let me see here. A negated disjunction is just not P and not Q. So we'll check that off. So here you see we have P and not P, and then Q and not Q, so this is closed, a closed branch. And so if you get a closed branch, then it is a tautology. All right, so just as a review, to check for self-contradiction, if it results in a closed branch, a completely closed branch, then you have self-contradiction. And for tautology, if the decomposition of its negation is a closed tree, then you have tautology. All right, have fun.